In this lesson, we will learn about a path and how to search for them in the network. In VZoom, a private transport path is routing on the network that connects geographical units of travel demand that we refer to as zones. We construct a transportation network that relates each zone to all of the other zones in the model. VZoom stores all the paths from an assignment. This is a powerful feature, and we have several built-in tools to take advantage of this. Let's learn the basics about these tools. First, let's look at how to view the shortest path in a network. Left-click on Graphics, then highlight Shortest Path Search, and left-click again. The Shortest Path Search dialog window appears, and we have some options in drop-down fields. At the top, we can select the type of object for the ends of our path. There is an option to select Zone, Node, and Main Node. We'll choose Zone for our example. Next, we have a choice criterion. This defines how a shortest path is calculated. We have options for free flow travel time, constrained travel time, impedance, distance, or an add val attribute. We'll select the free flow travel time, T0. We also can select the transport system if there is more than one and save the route index to an attribute. We'll discuss the route index in more detail in a few minutes. To find the shortest path, we'll initialize the feature and left-click the first zone, and once more for the second zone. Our shortest path appears. We can also go to the lists and select the shortest path search for our private transport system. Here are some details about the shortest path between these two zones. We'll go back to our network view now. You can toggle the choice criterion to distance, and notice the path changes slightly. VZoom allows you to see the effect of different metrics for evaluating the shortest path. You may also alter the coding of a network object to observe its impact on a path, even when you haven't executed an assignment. Let's change the choice criterion back to T0 and close the shortest path dialog with the left click. Notice the path stays active. The path will remain active unless it is initialized. Next, we'll select Links and then select a link along the shortest path. We'll change its speed to 0. Notice the shortest path changed because of the reduced link speed. The shortest path feature is helpful for network checking and when you want to explore alternative routing due to modified coding assumptions. This is an interesting example if we wanted to evaluate the impact of an accident or road construction where traffic is closed on a segment of the road. We'll initialize the shortest path and open the Private Transport Paths object in the Network Objects Type window and left-click on Paths at the top of the dialog. We don't have any graphic parameters to set for private transport paths, but they will appear the same way marked links are set. Here we have a drop-down to select the transportation system, and at the bottom we can select from all routes, a flow bundle, or filtered origin and destination pairs. Notice that there are multiple entries that have the same from and to zones. These are unique paths VZoom built in the Skim building process. We can open a list editor to evaluate these paths the same way we did for the shortest path search. Here, though, we have all the paths. In this section, we will learn how to generate a Skim matrix for private transport systems. First, we must establish parameters to calculate our Skim. To do this, we left-click the Calculator menu, choose Procedures, and left-click on the Functions tab near the upper left corner of the dialog. Private Transport Functions is listed on the left. Open the sub-items with the left-click on the plus symbol and choose Skims. The columns in this window tell us the type of Skim, its extension, default values for Skim matrix cells, and the range of minimum and maximum values allowed in the Skim matrix cells. The default diagonal is set with the left click of the value. You can then choose how the diagonal is calculated. In VZoom you have a variety of ways to establish the diagonal. We'll choose a constant value of 1 for T0. This means that the intrazonal time has a default value of 1 minute in our example. You can adjust the units for skims in the drop-down menus in the lower center of the dialog. Before we leave this window, notice the skim called impedance. There is an item in the private transport functions called impedance. This area defines the function that is used to calculate the impedance skim. We will left-click on impedance now to set parameters. Here you can define an impedance function for each private transport system. You may establish a unique function for links, connectors, turns, and main turns. To do this, toggle the In Detail box. If you want to use the same function for all objects in the impedance, the toggle is off, and you set the parameters by left-clicking Function. This opens the dialog where the function is defined by time, distance, a toll, an addVal attribute, or combination of these. Here, our impedance is based on constrained travel time and distance. Once we have established our functions and parameters, we can execute an operation in our procedures to calculate a skim matrix in our example. Left-click the Operations tab and create an operation with the left click on the Create icon in the right center. Open Matrices in this dialog and select Calculate Skim Matrix. Then, we need to select a demand segment. We'll choose the C-car demand segment and click OK. Next, we'll left-click the Parameters icon. In the following dialog, starting from the top, you may limit the zones evaluated in the skim process to those with demand. You may also filter the zones and analyze only the active. Just left-click the checkboxes to activate these settings. Just below, you may see the path choice criterion in the first drop-down. We'll select impedance as our method. Next, you choose the weighting of paths and whether you use paths from assignment. This setting is important for establishing feedback from the previous assignment to the creation of the new skim. Now decide what objects to include in the path building process by left-clicking the checkboxes. Once you have established how to build your paths, you define which you calculate and how to store the skim matrices. In the skims portion of the window, there are 4 columns. The first column is used to calculate a skim and hold in memory for the procedures. The second establishes if we will save the skim matrix to a hard drive or other permanent memory. If we check here, the output file section at the bottom goes from gray to active. The third column allows us to open a skim that has already been saved. The last tells us which skim we are calculating on any row. You can toggle all on, all off, selectively for either the Calculate or Save to File options. If a skim matrix is being saved, you will need to define the name of the output file, the format for saving the file, and check the mode if you want a warning to confirm overwriting of an existing skim matrix of the same name. To finish, click OK at the bottom. You may now make this operation active and execute the procedures. To see the resultant skim, we go to Demand, Matrices, and select the newly created skim.